In this video, we're going to be talking about the basics of setting up core data in your applications. We're not going to take a completely thorough deep dive to how core data works. I'm going to assume that you know a little bit already from having read Apple's documentation. But we are going to talk about some real-world usage, which will hopefully help you if you've never added core data to an application before. We're going to first talk about our example app to illustrate how core data might help you. We're going to set up the basic components of a core data stack, writing a basic in-memory version of that stack, and then extend it by adding support for asynchronous work in the background. And then we're going to show it a real-world use case of parsing data from a simulated API response to update the data in our persistent store. And then we'll show you two examples of how to get that data back out. First by making a simple fetch request, and then by using NSFetchResults controller as the backing store for a collection view. So let's start out by talking about our example app. So for this video, I have this little music app here. Let's think it works something like Spotify or maybe Audio. It's a combination of a music player and a social networking service. So the user can share music with their friends. They can keep track of their favorite albums as well as play music locally. For the demo purposes for this talk, we're just going to focus on this one screen, favorite albums. It's a collection view of the user's favorite albums. Right now I've got it hard-coded just to show this one record. So we're going to need to add core data in order to show some more stuff. So the reason that you would want to use core data in an application, there are actually several reasons, and this music app is a pretty good way of looking at what those reasons might be. So in our app, which I've codenamed Vinyl, we have a pretty complex data model. We're going to have albums, artists, tracks, users, and playlists, and each of these things has relationships to one or more of the other types. An album has an artist has multiple albums. Every album has multiple tracks, and every track both belongs to an album as well as an artist. We'll have users on our service, which may create playlists, and playlists themselves will have relationships to tracks. And although we have data backing all of this up on our web service, it can be really handy to have a local copy of this on the client side to help us manage traversing that object graph. And core data makes it really, really easy to set up these relationships. Another reason we'd want to use core data is core data also makes it easy to add offline support to your app. Even though the truth of all of our user data is living up in the cloud, the user may want to use the app while not connected to the internet, since it is a music player. And core data also makes it very easy to back up the latest copy of our local data model to disk, so it's available when the app launches again if we happen to have a cold launch while we're not connected to the internet. So let's look on how we build this data model here in our real app. I'm not going to build all of these objects today. I'm just going to build a few to give you an idea of how this works. So let's go to our Xcode project. The first thing I'm going to do is I'm going to create a group for all the new files we're going to create today. I'm going to call it core data. It doesn't really matter. So the first thing we're going to do is we're going to add a core data model. So you go to the core data section, choose data model, click next, give it a name. It can be anything you want. I prefer to give it the same name as the product, so that's Vinyl. Click create, and now we see in our navigator over here that we've added the vinyl.xcdatamodelD file. In the editing area here, you can see we have a couple sections: entities, fetch requests, and configurations. We're going to ignore fetch requests and configurations today, just focus on the entity section. So to add a new entity, you click this button down here, add entity. We're going to add an entity for albums. So we add an entity called album. We're going to add one for artist, and we'll add one for track. We'll leave it limited to that for now. When I select an entity, I see here I can edit three subsections: the attributes, the relationships, and the fetched properties for that entity. We're going to ignore fetch properties and just talk about attributes and relationships. So for an album, an attribute would be something like the title of the album. So we give the attribute a name, title, and we define what data type it is. It's a string. We can also give it, say, a release date, which would be a date. A relationship for an album would be, say, artist. In our app, every album has an artist. So the name of the relationship is artist, and the destination is another entity, the artist. And in this third column here, we see inverse. Core data relationships work in two directions, and there's no inverse relationship yet, so let's create one. To do that, we'll jump over to the artist entity and add a new relationship from artist to album. We're going to call that relationship albums, plural, because in our app, every artist can have one or more albums, so it should have a plural name. The destination is album, and now we can establish the inverse relationship to artist. One more thing to look at. When I've got this relationship selected here, if I look under the type in this detail pane over here, right now it's set to 1. We actually want it to be too many, because the relationship from artist to album is one to many. One artist can have many albums. The inverse relationship from album back to artist is okay to have as 2-1, because in our app, we're going to assume that every album only has one artist. Let's add another relationship, this time tracks. Every album has multiple tracks, so the destination is track. The relationship type is too many, because every album can have one or more tracks. And then we add the inverse over here. Every track in our app is going to belong to one album. The destination is album. We establish the inverse relationship, and it's okay for this to be 2-1. We're going to add 1 or 2 more attributes, and then we'll be done. For the purposes of this app, rather than pull images down from the network, which would be too much for a talk, I've already loaded a couple handful of album artwork images to the app bundle. So I'm going to add a artwork name property, excuse me, an artwork name attribute to our album entity, which will just be a string. It'll be the image name for that album. And to artist, we're going to add name, because we will need that for our demo. All right, so now we've set up the basics for our entities, and the next step is to create NSManageObject subclasses for these entities. You can do it all by hand, writing a whole bunch of boilerplate code, but that's kind of annoying, and Xcode provides a shortcut. If you've selected the data model in the navigator, you can actually go to Editor, create NSManageObject subclass. Here you see that the data model selected is vinyl. It's the only one in our app. That's okay. Then we click Next. We want to select all of these entities, album, artist, and track. We choose the location for the files it's going to generate, the language. Leave this option unchecked for now. We're not going to use that. And last but not least, let's pick the target group in our project. Click Create, and it creates NSManageObject subclasses for our 3 entities. Now you'll notice it's actually added 6 files. And the reason for that is a matter of convenience. Let's take a look at album here. So by default, Xcode provides a really basic definition of the class album. It inherits from NSManageObject. The properties are declared in another file. There's an extension of album where all the @NSManaged properties, this keyword here means that these properties are all managed by core data. These properties are defined in the extension. And the reason you can see here, there's this comment automatically added. Insert code here to add functionality to your subclass. And this is so in case you wanted to add something custom like helpful computed property. You could do this here in this file, and if you ever needed to use Xcode to regenerate the other file, it's not going to overwrite your helpful computed property. and let's see how that works. So let's go to our data model. We actually want to add an isFavorite property to our album. It's a bool. And editing this data model here does not automatically update the file over here. There is no isFavorite property yet. So we need to regenerate that class. We can do that by going to the editor again, create NSManageObject subclass, choose the data model, it's final. This time we are only interested in creating the album class. We choose our destination like before, our language, the target group, click create, and we'll see that Xcode has only recreated the file with the extension that contains the properties. We now have an isFavorite property, and if we go back to album.swift, we see that it has not deleted our helpful computed property. So that's a nice feature to use in Xcode. So now we've created our data model, we've generated NSManageObject subclasses for all the entities in our model. Let's get started on the next step. So next we're going to talk about the components of a core data stack. So a core data stack is separated pretty much in 3 tiers. At the bottom we have a persistent store, and this is where the actual data is kept. The persistent store could be in memory or it could be on disk. There's different types of persistent stores. The next tier up, there's a persistent store coordinator, which coordinates one or more persistent stores. It sits in between the lower level, which is the persistent store or stores, and the more, I guess you could say, user-facing level, which is the contexts. Your app may have 1, 2, or many NSManageObject contexts. Most of the time, your application's only going to need 1 or 2, probably 2. And although your app could also have more than one coordinator and more than one store, for 80% of the time or more, you're only going to have 1 store, 1 coordinator, and 1 or 2 contexts. And it's these 3 tiers considered all together that I'm calling a stack. And you'll see other people use that term too, a core data stack. So what we're going to do in this video is next create a class that helps us manage the creation and maintenance of this stack in a way that abstracts out some complicated business logic and also makes easier to make use of core data to the rest of our app. So let's go back to Xcode. We're going to create a new file. This time it's just a regular Swift file. We're going to create a class called core data stack. So first we're going to import the core data framework, and we're going to create a class called core data stack. It's important to make this a class because, as opposed to a struct, because we want the benefits of reference type. We want to control who has a reference to which stack and the lifetime of that stack, so a class is the right way to go. So at a bare minimum, the core data stack is going to need a context, so let's give it a main context property, which is going to be an NSManageObject context. We're also going to need a coordinator, which is an NSPersistent store coordinator. And technically we also need a persistent store, but we don't need a property for that. That's going to be managed implicitly by our coordinator. And last but not least, we need an init method to set up our stack. Now there's one important ingredient I haven't added yet, and that is the model. One cool thing about a class like core data stack is it's possible to write this class in a way that makes it really easy to reuse in multiple applications. It doesn't need to know anything about the kind of data that's being stored. It only needs to know just a reference to a model. So we're going to pass in the model as an init argument, and that is NSManageObject model. Cool, so let's get started. The first thing we need is a persistent store coordinator. And that gets initialized with a ManageObject model, which we've passed in to our init method. Next, we need to add a persistent store to our coordinator. So there's a very obvious method to do that. Add persistent store with type. For this talk, we're not going to talk about storing data to disk. We're just going to limit it to an in-memory store. So we're going to use the NS in-memory store type. Configuration, we're going to use nil. We don't need one. The URL, this would be a file URL if we wanted to store data to disk, but we don't, so we can pass nil. And last is options. Common use case for options is, again, if you're storing data to disk, there are some options you can pass that make migrations more easy, but we're not going to be doing that since our store only lives in memory, and there's never going to be a need for a migration from an old to a new store, so we can pass nil. I'm going to add line breaks here to make this method easier to read. We can see each argument without the line flowing off the end of the page. And we're getting a warning here because, like a lot of methods in core data, add persistent store with type throws. You're going to see this over and over again in core data. So we actually need to make our init method failable. I'm using a relatively recent version of Swift, so even though this is a class init method, we can actually indicate that this method throws, and we don't really care about the result here, but we do care whether or not it fails. So we're going to have let underscore equals try, question mark, and then try adding the persistent store with type. Cool. So now we know if we're able to get past this method at persistent store with type, we have a coordinator with an in-memory store. It's now safe to use. We can successfully finish initializing our core data stack. So let's set our properties. The coordinator is going to be the coordinator. The main context is going to be an NS managed object context. Now, in some older code references floating around the internet still, you may see people just initializing a context willy-nilly. That style of using a context is actually deprecated. You need to use the init with concurrency type. And we're going to be using two types of concurrency types in our talk today. The first is the main queue concurrency type. And that means that this context has been associated with the main queue or the main thread of your application. This is the context, in other words, that you're going to use to populate table views, populate collection views, to make fetch requests, to show data to the user. And you indicate that by this here. So now we have a coordinator, we have a context. I'm going to add some line breaks to the bottom of the page. Next, we need to establish the relationship between our context and the coordinator, so you can just set the persistent store coordinator property to our coordinator. And I believe that should be it. Now we have a very simple core data stack class. It's got a main context, it's got a persistent store coordinator, and everything has been set up and is ready to go. So we've written a basic in-memory stack, and now we're going to go on to section 4. We're going to talk about adding support for asynchronous work to our stack. And here's what I mean. So if you're writing an app like our music app, which is going to be pulling data down from the network, you're going to be getting a lot of JSON back. You're going to need to be parsing the JSON and updating your data model. And you need to do that in the background so that you don't block execution on the main thread, which would lead to a bad user experience. But core data has some very stringent rules around multi-threading, around asynchronous programming. You can't use a context on a thread with which it's not associated. So since we've associated this main context with the main thread, we can't use it in the background to perform inserts, updates, and deletes. We'll need another context that's been specifically associated with a background thread for that purpose. So let's add a new property. We're going to add a background context. And while we're at it, let's go ahead and add some pragma marks here so we can break up our public and our private members. So we're going to have some public properties for our two contexts. We're going to have some private properties. We're going to make the persistent store coordinator private because in our application we have no need to leak that out to anybody else in the app. And then we'll add one for our init and dinit section. All right, so we have a background context property. Now we need to initialize it. So we initialize background context in a similar way, NSManage object context init with concurrency type. This time we're going to pass the private queue concurrency type, and that means that this context manages its own private operation queue that you can use through a very specific set of APIs to access the context and perform reads or writes and what have you. So we've created a context and a background context. We also need to now associate our background context with the correct persistent store coordinator. And now that we have more than one context, let's give them each a name, which can aid in debugging later. You may not need this, but it's good to add it just in case you do. You can give it any name you want. We're going to give them some obvious names: main context and background context. All right, so are we done? Not quite. There's a problem. We have two contexts, so we have this one in the background that we can use when we're parsing responses from our web service. But changes that we make in the background are not automatically going to be reflected in our main context, which is a problem. Fortunately, Core Data provides a pretty straightforward means of merging changes from one context to another. And the way that's done is through a special NS notification called NSManage object context did save notification. It's a mouthful. And whenever that notification is posted, you can grab that notification and call another method on NSManage object context, which allows you to merge those changes. So we're using a pattern that I would call a sibling core data stack pattern, where our main and background contexts are siblings of one another. There's other ways of establishing a relationship between contexts, but that's outside the scope of today's talk. Suffice it to say, I really like this approach. It's one I've used a lot, I'm familiar with. It also happens to be one of the fastest approaches, if not the fastest, for certain kinds of use cases. And it's really a good fit for an app that is pulling data down from a web service. So the way it'll work is anytime we save the background context, we're going to merge those changes up to the main context. And anytime our main context saves, we're going to merge those changes back down to the background context. So here's how we do that. So first we need, in our init method, to set up some observations. So let's get a reference to the NS notification center, default center. And we're going to call the method add observer for name. This is the mouthful, NSManage object context did save notification. The object will be, let's start out with our main context. Q, we're going to pass nil. You'll see why in a moment. Using block, and this is the block that will be called anytime this observer gets triggered. Cool. So now anytime our main context is the object that of this notification, this block will be called. So what we're going to do is merge the changes from that main context to our background context using a very obviously named method, merge changes from context did save notification. Great. And now we'll add the inverse. Anytime our background context saves, we're going to merge those changes into our main context. Cool. Now there is a problem with what we have set up here. And the problem is, remember I said earlier that it's not safe to use a context on a thread with which it has not been associated. This notification did save could get posted from all over the place. So we need to make sure that we're only calling merge changes from context did save notification on the correct thread. And here's how we'll do that. So we're going to, instead of just directly calling this method on our background context, we're going to call self background context perform block. Perform block is one of a pair of methods that NSManage object context provides for this kind of thing. From inside of this block, it's safe to call almost any other method you want on NSManageObject context, including merging these changes. And now we need to do the same thing to our main context. So self.main context, perform block. Getting rid of these parentheses because Swift lets me and it looks nice. Cool. So now we are following the concurrency guidelines for core data. One more thing we need to do to be good citizens is add observer for name returns an NSObject protocol instance. So let's add a couple more private properties so we can unregister our observers. So we'll have a private var main context to save observer, and also add one for our background context. And let's set those properties here. So this is our main context observer, and we need one for our background context save observer. And then let's add a dinit implementation. If let observer is our main context save observer, and its notification center, default center, remove observer, and we'll do the same thing for our background context observer. All right, so now let's take another look at what we've got. We've got a core data stack that has a main context and a background context. We have a main context for doing work on the main thread, populating our UI. We have a background context that we can use for making changes in the background. And we are using NS notification observations to merge changes from one context to another as they're saved. Are we done? Not quite. There's one more thing that we need to do, and that is we need to handle merge conflicts. So it could be that changes are being made on both the main and the background context at the same time, since they're on different threads, and they could be in different states. And so once they both save, one is going to save before the other. And when a context is saved, it's pushing those changes down to the persistent store. So by the time the second one saves, what's in the store is in conflict with what's about to be saved. So we want to make sure that whenever we're merging these changes, that we know whether the version of the data which is in the context should win, or the version of the data that's already in the store should win, or whatever. So for our purposes, we're going to take advantage of the fact that we have this very prescriptive main versus background context sibling approach. And let that guide our choice. So what we're going to say is that since we're going to use our background context for parsing the latest data from our web service, we want the background context to always win against whatever's in the store. And we're going to also try to make sure that we only ever use our main context for reads rather than writes. It's not enforceable in the API, but it's just a good programming practice where you can swing it, because it helps solve problems like this. So anytime there's a conflict when merging into the main context, we want whatever is in the main context to be overwritten by what's coming up from the store. And here's how you do that. So main context, we're going to set the property called merge policy. And we're going to use NS merge policy init with merge type. And for this one, it's another mouthful. Remember, we want whatever is in the main context to be trumped by what's in the store. We're going to use merge by properties store, trump merge policy type. And for our background context, we're going to set the merge policy to NS merge policy merge type, merge by property object trump policy type, which means the copy of the object in the context. Those properties will trump whatever's in the store. And now I think this class is done. And again, since we're passing in the NSManageObject model into our init method, this class so far knows nothing about the fact that we're making a music app. So this is really reusable. So next we're going to talk about how to use our core data stack when we're parsing a simulated API response. So let's go back to Xcode. Now I have this class that I've added here called API Client. And again, remember this is a talk, so some of the code you're about to see is not at all what you'd be writing in production. This is mainly meant to simulate the kinds of activities that our app might do in a production application, so that we have something to work with when building our UI. In particular, I'm going to show you how this API client is being initialized with a context. We're actually going to be passing in our background context to make sure that we're doing all of this parsing work in the background. And to trigger all this fake behavior for our demo app, we're going to call this method simulate asynchronous background updates. So here's how you are going to use background context when you're parsing your data. So for a moment, let's ignore some of this boilerplate around the code. The money shot right here, we're calling self.context.performBlock. And this is how we make sure we don't violate the concurrency rules for core data. And we're going to call self.insertAlbum, passing some album data, which is a dictionary, and the context, which is self.context. And then we'll look at what insert album does in a moment. The other stuff here, we can kind of ignore it. It's, again, just for the demo. Every couple of seconds, we're going to insert an album so we can watch some collection view animations. So let's drill down into insert album and see how we make use of our NSManage object context to add some data. Let's add some line breaks here to make this a little bit more readable. So there's a little bit of boilerplate here and there when you're working with core data. It can be scary at first, but promise me it's not that bad. So when you're inserting a new object, in this case we're going to add a new album, you use the class called NSEntityDescription. Call the method insertNewObject for entity name. It takes a string. In this case, the string value needs to be album. We could have written it like this. You could also write it like this in Swift. You can pass a reference to the class as an argument to string, and it'll initialize a string equal to the name of the class. We could do something even cooler. Instead of our little helpful computed property here, we could actually add a static let entity name, which will be string album.self. And this will be handy in case we ever wanted to refactor and rename this class. We have some compile time guarantees that we're going to be having a proper string value for entity name, as opposed to a magic string floating around loose. So let's replace that. Instead of string album self, we'll just put album.entity name. And that'll be a lot more handy. So we insert new object for entity name in manage object context. This method returns just an NSManage object, so we know it's going to be an album. So this is a case where we would force cast this album object to the album class. So now we've inserted a new album. We can start to populate some of its properties. We set the title. We set the artwork name. We're just pulling some data out of our data dictionary to do that. Again, this is a talk, so this in production you're going to have much more sophisticated parsing, but for now we just unpack some of the data that we need to make a new artist. So we get the artist data, which is another dictionary. We use NSEntityDescription to insert an artist into our context. We set the artist's name, and here's something really, really cool. Look at this right here, album.artist equals artist. This in one line does so much stuff that would save you a lot of code if you tried to use something other than core data or write something yourself. By just setting the property artist to this new artist, we've established both directions of the relationship. We've said that this album's artist is this particular artist, and we've also added this album to that artist's set of albums just by this one line of code. That's really cool. This is one of the biggest reasons why you'll want to use core data for this kind of an application. So now we've set up the basic properties that we need for our album and our artist. The last step is to call, this should not be self dot. This should just be context save, where we're actually going to save the current state of our context to the persistent store. Like a lot of methods in core data, this method can throw, so we need to wrap it in a do catch. And if we get an error, we're going to print the error. In our app, we're not going to hit an error. And many times in your apps, you're probably not going to hit an error. You might hit an error if you have configured your data model in such a way that you've made certain attributes or relationships required and neglected to, say, set the artist relationship on your album. But for completeness, I'm printing the error. We're not going to hit that error. And that's it. Setting up the properties after inserting a new object and calling save, you have now added that object to your persistent store. So that was a quick look at our API client class, which is going to simulate the kind of stuff that's going on when we're parsing an API response from our web service. So now let's change gears, and instead of writing data, we're going to look at how you read data out of your persistent store. So remember, we're building this app that in our demo just has the one screen with a collection view of albums. So this collection view, I've given it a little one-off class as its data source. The class is called album list data source. I've overridden only the most basic methods here: number of sections, number of items in section, self for item and index path. And right now they're just hard-coded to one section, one item in that section, and some hard-coded values. So let's update this class to actually pull real data out of our persistent store. So first we're going to give it a designated initializer that's going to accept an NSManage object context. I'm not getting code completion because I need to import the core data framework to use that symbol in this file, NSManage object context. There we go. And there's a couple ways we could write this class. Let's start with one that's really naive. Let's say we're going to give this class a private property, and we're going to call it let albums, and it will be an array of albums. We could do that. And here's how we would fetch them. So I'm going to we're getting a warning here because we've not satisfied the compiler for this init method. We'll get to that in a minute. First, let's add a little private methods section here. Add some more breaks so we can center our work. We'll give it a private static convenience method called fetch albums from context. And this is going to return an optional array of albums. So here's how you fetch some objects from your persistent store via an NSManage object context. First, you create an NSFetch request. NSFetch request initializes with an entity name. We can use our convenient entity name static property that we added. So now we have a request. We could, if we wanted to, further modify our request, but we're going to keep it simple right off the bat. To fetch objects, our results are going to be context, execute fetch request, we pass the request, and we're going to get a compiler warning because execute fetch request, you guessed it, throws like everything else in core data. So here's what we'll do. We need to add a do catch block. We don't care about the error in this case for this method. So return try execute fetch request returns an array of any objects. So we also need to safely cast this array of any objects to an array of albums. And if our execute fetch request call through an error, we are going to return nil. Now the compiler should be happy that we satisfied every basis path. Cool. So now we have this fetch albums convenience method. So we can now update our init method to set our albums property to album list, data source, fetch albums from context. And remember that returns nil. So we'll use the nil coalescing operator to provide a fallback value of an empty array of albums. And now we'll call super init since we've inherited from NS object. Cool. And so at this point, we would take our albums array, which is non-optional, and we can update number of items in the section to return albums count, and so forth. Are we done? No, we're not. We have a pretty big problem hiding in this approach. The problem is that this albums array is really inert. If we need to insert or delete or reorder our albums, we're not able to do that. In addition, we said we're doing all of our parsing in the background. So if we're doing something in that background context that's going to change what we should show here in this collection view, we're going to merge those changes into our main context, but that's not going to get reflected in this array. So there's two ways we could go about it. One way is writing a whole bunch of custom code that's going to observe for the changes that are going to affect what we need to display. We're not going to do that. Instead, we're going to use a class that Apple provides called NSFetchResultsController, which is going to allow us to get all of that behavior for free. So instead of an albums property, we're going to have a fetched results controller property, which is going to be an NSFetched results controller. And for reference here, we've now executed a simple fetch request, so now we're going to move on to this last section using a fetch results controller with our collection view. All right, so we've defined our fetch results controller, we've declared our property here. Let's change our convenience method here from fetch albums to new controller with context, and instead of an array of albums, it's going to return an NSFetchResultsController. When you initialize an NSFetchResultsController, you're going to need an NSFetchRequest, so we can leave this. And we need to add something to it. NSFetchResultsController needs a fetch request that has at least one sort descriptor so it knows how to sort the results for you. So let's create a title sort. We're going to sort our albums by their title. So we initialize an NSSort descriptor using the key. This is the name of the property, which is title. That's the name of the attribute from our data model, which we defined at the beginning of this video. And ascending will be true. And then we set the sort descriptors property of our fetch request to an array with one member, which is our title sort. Now we can initialize an NSFetchResultsController, passing our fetch request, our context, a section name key path. We'd use that if we needed to break our albums into sections. We don't. And a cache name is something we'd use if we were having performance problems because our fetch request was really complicated. It won't be, and we don't need it. So we'll pass nil for the cache name as well. All right, so now we've updated our convenience method to create a new fetch results controller. Let's now update our init method. We're no longer using an array of albums. So fetch results controller equals album list view controller, album list data source, new controller with context. Cool. There's a little bit more we need to do. You can't just initialize an NSFetchResultsController. You got to do two more things to it. The first is you need to get it going by calling its performFetch method, and the second is you need to provide a delegate. So let's start with that first one. So we're going to call fetchResultsController performFetch, and you guessed it, it also throws. So let's be good citizens, provide a do cache block, try performFetch. If we get an error, let's log our error. Error performing fetch. And last but not least, we also need to provide a delegate. So the fetch results controller is maintaining a dynamic fetch into our context based on the fetch request that we gave it. So anytime changes get merged into our main context that should change our results, the fetch results controller is going to automatically update its results and then tell its delegate that it changed its content. So we're going to extend album list data source so it becomes the delegate of its fetch results controller. So let's provide an extension here. Album list data source. We're We're going to have it conform to NSFetchResultsController Delegate. There's a number of methods we could use. Let's start with the most basic one. So we're going to override, we're going to implement controller did change content. And in here, we're going to need to reload our collection view. So anytime our main context, anytime the fetch results controller detects that there's a change that should affect its results, it's going to update its results and then call did change content. So let's update our init method so we can pass a collection view to our data source here so that we can have very convenient access to our collection view. Provide a property for it. Update our init method so that we're setting it. Self.collectionView equals collection view. And now inside of controller did change content, we can reload the collection view very simply just by calling collection view reload data. And one more thing we need to do is we need to set ourselves as the fetch results controller's delegate. So fetch results controller dot delegate equals self. Cool. So now we need to update a few things that are broken in our app. We've updated the initializer for the album list data source, so we need to go to our view controller and make sure that we've updated our view controller. So we're going to need a couple things. Our view controller is going to need a reference to an NSManage object context. In this case, it's going to be our main thread context. I'm not getting code completion because I need to import the core data framework into this file, NSManage object context. And I also want to add an API client so we can simulate some data parsing from our web service. Let's update. I have this factory method here, new from storyboard. I'm going to update it so it accepts two arguments. It's going to take a context, NSManage object context, as well as an API client. And we're going to set the context property of the album view controller. We're going to set the API client property. And inside of view did load, we're going to create our album data source, which gets initialized with our context and our collection view. Our collection view property is from our storyboard. And by the time view did load is called, we know we have a collection view, so we can safely initialize our album data source. And you'll also see here, I've set the collection views data source to our album data source, in case you were curious. One more thing I'm going to do is I'm going to override view did appear, just so we can simulate our fake API response parsing. So we'll call API client simulate asynchronous background updates. Awesome. So let's see. Class album view controller has no initializers. We need to make these properties implicitly unwrapped optionals. That's a side effect of my factory method here. Cool. And now we'll go to the AppDelegate and update that as well. So here's a good chance to see how you actually initialize our core data stack. We didn't do that earlier after we declared the class, implemented the class. So our album view controller is going to need an API client and a core data stack. We're going to have our AppDelegate be the thing that makes sure we have a persistent, strong reference to these dependencies for the lifetime of the application. But we're going to make these private properties because we don't really need to let anybody who wants to have access to them. So we're going to have a core data stack. And we're going to have a API client. I'm making them implicitly unwrapped optionals because this is a talk. In a production application, you're going to need a lot more sophistication around the management of your global dependencies. But for now, we can get away with this. We need to import core data because we're about to use it. Okay, cool. So in app.did finish launching with options, we need to initialize our core data stack. So let's initialize that. It takes a model. Where do we get a model? Well, let's make one. NS manage object model. We're going to use init with contents of URL. This is a file URL for the model in our app bundle. So let's get the model URL. We're going to get that by calling nsBundle main bundle URL for resource. I'm going to pass the name of our model. Remember, we named it after our product name, vinyl. And the extension is actually MOMD. It can be confusing. You may look over here and see XC data model D. You actually need MOMD. Even though this method is designed to return an optional, we want to force unwrap these, because if we're ever in a situation where we don't have a model in the app bundle, or it doesn't have a valid URL, or who knows what, we want to fail as soon as possible. That just shouldn't happen. All right, now we're still getting a compiler warning on core data stack, if you'll recall, because this call can throw. Remember, when you add a persistent store, it could fail. So let's provide a little bit of safety here. Add a do catch block. Try. In a production application, you're actually going to need to handle this error. The kind of error you would get if you're unable to initialize a core data stack, most common is going to be you're storing your data on disk and you're migrating from an older to a newer version of the model, say your 1.0 to your 2.0, and there's some incompatibility you haven't tested for, and so the migration fails and it's going to throw an error. And so your response would be either to manually migrate the data from the old store to a new store, or just blow it all away, remove the files from disk, and start from scratch. The latter is a lot easier and works pretty well with apps that are pulling data down from a web service. But since this is a talk, we're just going to bail early with a fatal error, unable to create a core data stack, and log the error. So now we've got a core data stack. Let's initialize an API client. This one gets initialized with a context. We're actually going to pass the background context to this because we want to make sure that our API client is only using a background context so as not to block the main thread. Cool, so now we have our two main dependencies. We can update our album view controller context, core data stack, main context, API client, API client. So we've set up our core data stack on launch. We've set up our API client, passing a reference to the context that it needs. We've set up our album view controller, passing a reference to the context that it needs. Is there anything else that we need to do? I don't think so. Let's build and run and see what happens. So remember, on view did appear, our album view controller is going to start inserting albums. Now this is still the old version of the app where I've got a hard-coded album here. Oops, we got a build error. Let's fix that. Oh, almost forgot. We have our album list data source class, which I added the fetch results controller property, but I have not updated our collection view data source protocol methods to provide the appropriate values. So let's implement number of sections in collection view. To do that, we're going to call fetch results controller sections as an array of section info objects. This array is optional, so we'll do question mark count and then a default value of 0. For number of items in section, we'll do something similar. If let section info equals fetch results controller sections, then we'll subscript the section index. Otherwise, if we don't have any section info, there are no items in that section, so we'll return 0. And if we do have section info, let's look at this real quick. The section info is an object that conforms to NSFetchResults section info protocol, has a handy getter number section info dot number of objects. Awesome. So now we have number of sections, number of items in each section. Now we're going to implement cell for item at index path. So let's expand this method here. So we've dequeued an album cell, and right now it's still set to this hard-coded stuff. We're actually going to pull the real deal. So let's start with something basic like let album equals fetch results controller object at index path, and we can just pass the index path from our collection view data source method. This method here, object at index path, returns an any object. So we actually need to cast it to an album. And if we wanted to be cowboy about it, we could just force unwrap it to an optional to an album. And we're going to be a little bit more responsible to show you how you should do it in production. If let album equals that as an album, then inside of this if let, we're going to update our cell. Now we've got our album. So if let artwork name, we're going to get the name of the artwork from our album. Now why am I calling if let artwork name? That is because if we look at the core data properties, they're all defined as optionals. That's by default when Xcode generates this class. I highly recommend that you continue to leave those as optionals. Even if you think you're never going to accidentally forget to set or retrieve those properties, you just don't want to guarantee, you don't want to set yourself up for a potential bug in the future. So leave those as optionals and unwrap your optionals safely. So if let artwork name is the album artwork name, then we now have a safe artwork name string which we can use to initialize an image view. We're going to do the text for the artist label, album.artist.name, and UI label doesn't care if its text property is nil, so we don't need to add an if let for these. Neither do we need to do that for the album title. Cool. So now let's build. Build succeeded. Now we should be able to build and run. Now remember, anytime our favorite albums view controller appears, it should start every couple seconds inserting an album. So let's see what happens. And there we go. We're inserting albums. Now it's not very pretty. There's no animations here because every time a new one is inserted and we're saving the context, we're just calling reload data on the collection view. But that's a good start. We're now pulling data that we've written to our persistent store. So for the last step, let's see how you can actually make this animate. So let's go back to our album list data source class. Remember, this is our collection view data source. It's also an NSFetchResults controller delegate. We've only implemented controller did change content. Let's talk a little bit how NSFetchResults controller works. So there's actually 3 methods we're going to need to use for this video. Controller will change content, controller did change content, and in between, the method called did change object at index path for change type, etc., etc. And here's how this works. Let's say you've inserted, deleted, and updated a handful of albums, and then called save on your context. We're doing that in the background. That triggers a merge up to our main context, and that triggers the NSFetchResults controller to update its contents. And there's a sequence of events that happens in a row, all in the same turn of the run loop on the main thread. So the first thing is it's going to tell the delegate, I'm about to change my content. Then one or more times it's going to call did change object every time an object gets inserted, updated, deleted, or moved. And then at the end of that sequence, it's going to call did change content. So if you were using a table view instead of a collection view, in will change content, you'd probably call, table view begin updates. In did change content, you would call table view end updates. And then in here, you're going to do your insert, delete, blah, blah, blah. It works similar to that with a collection view, but there's an API mismatch with UI collection view because in controller did change content, you can't call an end updates method. You actually need to call collection view perform batch updates, passing a block of updates. So how do we get all the changes that are happening in this method inside of this perform batch updates block? Well, there's a pretty novel and ingenious approach that was invented by internet friend of mine, Ash Fro, who works at Artsy. The open source code is no longer available, but I like his approach. Basically what he does is he has a private property, we'll call it something like change operation, which will be an NS block operation. And most of the time it's going to be nil. And instead of calling begin updates, inside of will change content, we'll say change operation equals NS block operation. We'll initialize a new one. And then every time this is called, we're going to add an execution block to our change operation. And then at the end, in did change content, we're going to call self.changeOperation start. You don't actually need to enqueue an NS operation with an NS operation queue. You can just call start and it'll work. All right. So now let's implement this method here. So this method is controller did change object at index path for change type new index path. Let's look at change type. So this NS fetch results change type has 4 possibilities: insert, delete, move, or update. Very easy to understand. So we're going to add a switch. So we're going to switch around the change type. It can be insert. I'm just going to add breaks for now and add proper implementation in a bit. Insert, delete, move, or update. Now let's implement one of these to see how it'll work. So for an insert, we're going to call self.collectionView insert items at index paths. And since this method only calls one index path at a time, we'll just pass that index path. Now look here, the index path is actually optional, so we need to safely unwrap it. If let index path equals index path. Now we've unwrapped the optional. And we're not going to call this immediately. We're actually going to add this as an execution block to our change operation. So we're going to call add execution block. Get rid of the extraneous parentheses. And even though this change operation is optional here, we are going to assume that because we know NS fetch results controller is so reliable that we'll have a change operation. Because will change content is always going to be called for this method fires. And let's do something similar for the delete, move, and update change types. So for delete, we're going to delete items at index paths. For a move, we're going to need both the old and the new index path. And we're going to call move item at index path to the new index path. And for update, we're going to call reload items at index paths. All right, so let's review. Anytime we're going through a change sequence, the first step is the controller will change content. So we set a new change operation. Then one or more times, this method will be called for each change type. And for each of these calls, we're going to add an execution block for an insert, for a delete, for a move, or for reload items. Oh, I have a typo here. When we're inserting, we actually need to use the new index path. That's the property that will be provided. Okay, insert, delete, move, and update. And then at the end, we'll start our change operation. So now let's build and run. And hopefully we should see that as our albums are parsed in our simulated API client, each album should be inserted with an animation. The new album will fade in, and if there's a reorder, yep, there we go. We have a nice looking animation here. And there you have it. We've built a little demo app based on core data where we're simulating the parsing of data from a web service, inserting it into our background context, merging those changes into a main context automatically, and piping those changes into a collection view with the help of NS fetch results controller.